Dude, I'm kind of hungry. Let's make mac and cheese.
Same, man. Let's get cooking.
Okay, let me get this water boiling.
Ooh, convection.
What's that?
It's the energy transfer through liquids and gases. Duh.
Okay, so this boiling water is an example?
Yeah.
Got it.
Oh my. It's really cold out there.
Haha, sucks for you. I'm warmed by the fire.
I know. I can see that.
I may have something that can help you.
Please, fill me in.
Here, take this. Best hot chocolate you'll ever have.
Why would this help me?
Because it's a thing called conduction.
What the heck is that? I don't study.
It's thermal energy transferred through direct contact.
Okay, but doesn't that mean my cold hands can make the drink cold?
No, not necessarily, because thermal energy always flows from hot to cold.
Sweet, dude.
But the drink will eventually get colder because some of the thermal energy has left.
Okay, I get it now. Thanks, broski. Dang, it sure is hot in this car.
I know, the heat isn't on though, so why?
Maybe it's radiation.
I don't even know what that is.
I think it's the energy transfer through electromagnetic waves.
So like a hot car in summer?
Yeah, like this. Ugh.
So how does this work?
Sun's rays heat up the air inside the car, but the air has nowhere to go, so that's why it gets so hot.
Oh, okay. I get it. Thanks.
You're welcome. Molly, what are you doing? That smells so bad.
I'm doing an experiment with vinegar and baking soda.
Why?
Because I want to see the chemical reaction.
What's a chemical reaction?
A chemical reaction is the process by which one or more substances change to produce one or more different substances.
Okay, show me.
Here we go. Ooh.
Whoa, that's pretty cool.
Do you want to see the chemical equation?
What's that?
It's a symbolic representation of a chemical reaction.
Okay, show me.
This is the chemical equation for vinegar and baking soda. This is a chemical formula, and so are all of these. These are the reactants, the formulas before they go through the reaction, and these are the products, the outcome of the reaction. This is a subscript. A subscript is a number to the bottom right of a letter that shows how many atoms are in a molecule. This formula doesn't have any, but a coefficient is a number to the left of the letter that shows how many molecules there are. For an example, this would be a coefficient.
Wow, you're really helpful.
There's still one more thing I need to teach you about chemical equations.
What's that?
The law of conservation of mass. The law of conservation of mass states that mass in an isolated system is neither created nor destroyed by chemical reactions or physical transformations.
Wow, anything else?
Actually, yeah, balanced equations.
What are those and how do we make them?
Well, to follow the law of conservation of mass, we must balance the equations. A balanced chemical equation occurs when the number of the different atoms of elements in the reactant side is equal to that of the product side.
Example?
Of course, I will quickly show you how to balance an equation. So, what you want to start to do to balance an equation is write down the number of each element. So on this side there's 1 carbon, 4 hydrogens, and 4 oxygen. On this side there's 1 carbon, 2 hydrogen, and 3 oxygen. This is unbalanced. But to balance it, we can add numbers, coefficients, to the outside of the letters. So to make this 4, we can add a 2, and it becomes 4 hydrogen. That's one step closer to balancing this equation. Since we added this, that also makes this 2. So now we have 1, 2, 3, 4 oxygen. And now our equation is balanced.
Thank you so much. I finally understand chemical equations.
That water earlier, I really wish it would have boiled faster.
You know there are 4 ways to increase the reaction rate?
What?
Yeah, you can increase the temperature, surface area, or concentration, or you can add a catalyst.
What are some examples of those?
Well, if you put glow sticks in hot and cold water, then the glow stick in the hot water will become brighter faster, because the increase of temperature will increase the reaction rate.
Okay.
An example for the surface area is if you cut up potatoes into little pieces, then the smaller potatoes will cook faster.
That's good advice because I love potatoes.
When you increase the concentration, the reactants come into contact more often, which causes the reaction to occur more quickly.
What about a catalyst?
It's a substance that increases the rate of a chemical reaction without itself undergoing any permanent chemical change, which, for example, is like when you add vinegar to steel wool. Steel wool has a faster reaction, the vinegar is unaffected.
Wow, I feel very informed on these. Thanks.
Induction.
It's thermal energy. No, not necessarily, because thermal. Stop! But the drink will eventually get cold. It's a symbolic representation of a chemical reaction.
What are balanced equations and how do we make them?
Well, to follow the law of conservation of mass.
I don't even know what that is. Dang, it sure here is hot and I can't. Sun's rays heat up the carton.
No!